Welcome to Lesson 3, Variables. In this topic 3, we're going to explore how we can use mathematical operations to modify the values of our variables. And then we're going to connect it to the Circuit Playground Express and see some interesting things we can do with the NeoPixels. So let's get to it. So in previous videos, we saw that we could use variables to store information as well as possibly retrieve the values from the Circuit Playground Express. In this video, we're going to go back to this notion of variables. We're going to have our own internal variables, our own internal information that we're going to use as part of our program. So I've created a variable called POS, which is going to stand for position, which again, we're going to connect this with the set pixel color function of the Circuit Playground Express in a little bit. But let's just explore ways that we can modify this variable. So if you go down to the loop, I've introduced our first way that we can modify our variable, which is simply to increase it by 1. So this nice little operator, the plus operator, will do exactly that. And let's go ahead and use our serial monitor to investigate what's happening here. And let's offer a little delay. Only from experience, I know that this is going to go really quick. And let's say a delay of 2000. So we have a little bit of time to kind of look, explore, and talk about what's happening. So I think I got everything correct. Let's go ahead and upload it. Let's pull up our serial monitor. And let me clear out the output. Okay, so we can see here what's being printed out is the value of POS. Now, because this is part of a loop, it's repeating over and over again with a small delay of 2 seconds in between. And what you're seeing is that the numbers are simply increasing by 1. That's what this operator does. Plus will increase the value of POS by 1. Now again, you might say, well, why would you want to do that? And that's what we're going to get to towards the end of the video. But let's explore some other ways that we can modify our variables. So hopefully you can kind of imagine that if there's a plus, there's a minus. And let's see what that one does. Now if you recall, POS starts at 0. So, and you might also ask, why is there no -1? Well, there's a slight delay between the Circuit Playground Express communicating back to the serial monitor. So something to note when you're working with the Circuit Playground Express, that there is a communication tunnel between the two. And you may have to adjust a little bit of your variables in order to get the desired numbers. But just as before, we saw that it is modifying the value of POS, except this time it's decreasing it by 1. Again, you might say, why would we want to do that? You'll see here in a little bit. All right, so let's explore another way, a couple of other ways that we can modify our variables. Now, the minus and the plus are restricted to only increasing or decreasing the value by 1. There is another combination of operators that we can use. These are called shorthand operators. So if I do a plus equal 1, it's going to do the same thing as the plus. And let's investigate that. And you can see here we're getting the same values as 2, 3, 4. It's increasing. The benefit of using this notation to modify the value of a variable is that we don't have to necessarily increase by 1. We can increase by whatever we want. We can increase by 5, for instance. As you recall, with the plus and the minus, we can only increase or decrease by 1. This, using this shorthand notation, allows us to increase by other amounts. Alright, so here we got 10, 15, 20. So you can see you were increasing by 5 each time. Now, obviously, if you see the plus here, you also can imagine we could also decrease by that amount. Technically, you can use any arithmetic operator here. Now this one might be a little tricky. I'm going to change this value to 1. So what's going to happen here is that every time our loop goes through, we're multiplying the value of POS by 2. So if I multiply 1 by 2, it becomes 2. POS becomes 2. And now I'm going to multiply the 2 by the 2. And this is probably a little harder to understand. Practice will help you appreciate what's happening with the multiplication. But if nothing else, let's just observe the values. They might make more sense. Notice each time I'm multiplying the value of POS by 2. And hopefully you could also appreciate some of these numbers. You have seen these when we've talked about binary operations, that these are the place values that go with the binary number system. So again, maybe a very convenient way of getting all those place values, so you can maybe do some other type of operation. All right, so let's go back to our original idea, which was to increase POS by 1. And this time, let's do something with that variable. And what we're going to do is we're going to, let's use that variable, which is going from 0, 1, 2 as the variable, as the value, set pixel color, of that first argument in set pixel color, which is a position. And let's simply do 255, 0, 0, which will color it red. Let's run it. Let's pull up our serial monitor. Let's pull up our camera. And what you'll see here is that, notice, with each new value of POS, a new neopixel is being colored. Now again, if you feel like it's going a little on the slow side, that's because we have the delay of 2000. You can modify that. But I wanted us to be able to talk about this. Now if you look at the serial monitor, notice POS is still increasing. 10, 11, 12, 13, 14, 15. Those aren't valid positions for the set pixel color. We don't have a neopixel at position 18. So something we're going to have to consider here in a little bit in another example. So I think something that also looks nice when I explore neopixels is to clear the pixels out before I do anything with it. Think of it almost like clearing the canvas and then drawing something new. So sometimes depending on the application, I will always clear the pixels first, so I have a clean circuit playground, and then I color the neopixels that I want. And let's see the difference in this in the output. So notice by clearing the neopixels, now it feels more like the neopixel is traveling around instead of just turning all the neopixels on. But this is definitely going to bring more to light the issue that we have right now. So notice POS is at 10, but there is no neopixel 10. Our minds would have, I guess, appreciated that when it got to this last neopixel that it cycled back around, but it hasn't. So that's what we're going to do with this next operator that we're going to discuss, which is called the Modulus Operator. And for this, I'm going to just comment out these two lines, just so we're not focused on them. And what I'm going to do here is, the Modulus Operator is the % operator. What it does is that it returns the remainder of the associated division. You know what? I'm going to go a whole different route. Let's just take all of this out and let's just do a couple of hard numbers. 10 modulus 3. So if I was to divide 10 by 3, the remainder would be 1. So I think at this point we just need to appreciate what the Modulus Operator is going to do before we try to incorporate it with our Circuit Playground Express. Okay, so notice it's giving us 1. Again, this modulus operator gives us the remainder of the associated division of these two numbers. So 10 divided by 3 is 3 with a remainder of 1. Again, you might think, how is that useful? Well, let's bring this back in now. And let's divide this by 10 because we got 10 neopixels. Now, in the previous example, we saw that if we simply printed out the value of POS, it just kept on increasing. I want you to see what happens now. Oops. Wrong one. 0, 1. So we're still getting our 2, our 3. I guess I could have increased a little bit more. That's going to take a little bit to get to the 10, but that's okay. Again, it's a good way to process information. So we got the 7, the 8, we got the 9. Notice we don't get to 10. Reason being, POS is still increasing. The value of POS is still 10. But the value of 10 divided by 10 is 0. Okay, let me do this a little bit differently, and I think it might make more sense as to what's going on. So let's do a serial print of POS by itself, because I want you to see that POS is still increasing. Let's do a little, typing too fast, slow down. And let's do a little tab here. And that way we can make this last one print outline. And let me reduce this down to 1 second and a half. So POS by itself was our original solution of just using that with the Circuit Playground Express. And notice, 2 divided by 10 is 0 with a remainder of 2, and so on. The interesting thing comes down when you get to 10. Notice the value of POS is still increasing. But when you do 11, for instance, divided by 10, it would be 1 with a remainder of 1. Notice how the numbers are cycling now. This is an interesting way to use the modulus operator to bound a certain value of a variable within a particular range. All right, so let's see this work with now our Circuit Playground Express. So instead of just doing POS, I'm going to do POS modulus 10, which will bound the value to 0 and 9. And actually, I think at this point it might be just nicer to decrease a little bit more. We've seen what's happening with the values. I'll still bring up the serial monitor, but it'll be cooler to look at the Circuit Playground Express. So you can see here the neopixels going around, but the interesting thing will be once it gets to that last one. Notice it's cycled back around. Again, we're using the second column now. And notice that the modulus operator allowed us to keep it within the range we want. Now obviously at this point, let's have a little fun. Let's make this 200. So it kind of spins around a little faster. Actually, 200 might not even be that fast. Let's see. But hopefully you can appreciate this is about information that we chose to track inside the Circuit Playground Express. Again, this isn't coming from some input. This is some random value. This is a variable that we created to control the position of the neopixel. So hopefully you've enjoyed this. Let's go back to our presentation and let's review what we've done. So in this lesson, we furthered our understanding of variables and how we can use mathematical operations to modify them. Specifically, these shorthand notations to increase and decrease, or even exponentially increase using the multiplication operator to adjust the values of our variables. We also explored the modulus operator, which returns the remainder of an associated division. Now, one of the interesting applications of the modulus operator is that it can also be used to bound the value of a variable within a certain limit. So I look forward to seeing what you can do with these mathematical operations. Enjoy.